Worksheet 4.6 for Algebra 2, I'm going to look at numbers 14 and 16, which are both solving systems of equations. This is for concept 4. And in number 14, it's pretty straightforward in the beginning. They both have y equals. And when you have that, you could do substitution. It's absolutely reasonable to do that. But for this one, the way it's set up, it's more likely for combination. Or I'm sorry, that backwards. It's more likely for substitution rather than combination. Now you could use combination, and there is a way to do that. But for this one, substitution might be quicker. Now for substitution, remember that means since we have y by itself, this entire quantity gets plugged into the y in the other equation. Now what's nice here is that this is just a 1y, which means none of this changes. It's like we plugged in a 1 and then we plugged in 4x minus 9. There's the 1 from in front of the y equals x minus 3. And then we distribute the 1 and again nothing changes. So it stays like this, x minus 3. Then we start solving for x. We move x's on one side, subtract the x's. That cancels, leaves us with 4x minus 1x is 3x. Add 9 to both sides. Negative 3 plus 9 is positive 6. And then I'm going to divide by 3 and I get x equals 2. So my x coordinate for my solution is positive 2. Then I have to choose one of these to plug back into to solve, and it looks like this is going to be definitely the easiest one. So if I plug the 2 into this x, that becomes 2 minus 3, which is negative 1. So my y coordinate is negative 1. Now the other one I wanted to do was number 16. And when you look at 16, it's pretty insane because you have some much larger numbers to deal with and you have these ugly fractions. And what I'm going to do first, I want to get rid of the fractions first and then look at the equations at that point, compare what I have. So for this set, this second equation, my greatest common denominator is 18 because both 9 and 18 divide into 18. So what I'm going to do is I'm going to multiply that whole line by 18. So this first equation isn't changing. That's still negative 24 minus 8x equals 12y. This becomes 18 from 1 times 18. Now when I multiply 18 times 5 over 9, that becomes 18 times 5 over 9. And if you're clever, you can do some canceling here. 9 goes into 18 once, twice. It cancels on the bottom, leaves us with 2 times 5. That gives us 10, so it's plus 10y. Then on the other side I have negative 7 over 18. So I have negative 7 over 18 multiplied by 18 over 1. And again, canceling 18 and 18 cancel, leaves us with negative 7 over 1. So in other words, just negative 7x. So now I got rid of the fractions, so it's a little bit nicer looking. Now let's look at what we have left. We have our constant value here, but the number by itself. We have our x term and our y term. Here we have our constant term, our y term, and our x term. So things aren't quite lining up here. What I'm going to do is I'm going to move it so that I have x's and y's all on the same side. Now there's a lot of different ways you could go from here. You could solve for y, you could solve for x. The reason I'm not going to do that is because if I solve for y, now divide by 12, I'm going to get fractions. It's going to bring those ugly fractions back. And I think there's a way to do this without those fractions. So what I'm going to do is I'm going to keep the negative 24 and the 18 where they are. So on my next line, negative 24 will stay where it is. I'm going to move this negative 8x over it. So it becomes positive 8x plus 12y. Then on the second line, this 18 will stay where it is. And I'm going to subtract this 10y over, so this negative 7x is going here, minus 10y. So it's a little bit nicer. Now I've got x's lined up and I've got my y's lined up. Now from here, the way I've set it up, this is going to be setting up more for combination than for substitution, since I have all the x's together and all the y's together. One thing we should look at is which of these we then want to make cancel. And it looks like the x's might be easier because they're slightly smaller numbers than dealing with 12 and 10. So what we're going to do now is we've already got a positive and negative. We want these to cancel. So we want them to be the same absolute value. So the easiest way to do that is just think 8 times 7, you get 56. I don't think there's a smaller number that works there. No, there isn't. So now I'm going to take this top equation, and you're starting to see why this problem is fairly insane. I'm going to take this top one, I'm going to multiply by 7. I'm going to take the bottom one, I'm going to multiply by 8. So now this result gives me negative 7 times 24 is 268 equals 56x plus 84y. On the bottom, when I multiply by 8, that gives me 644 equals negative 56x minus 80y. Now if I've done this right, the x's should cancel, which they do. 56 minus 56 cancels. When I combine negative 168 with positive 144, I get negative 24. On this side, when I combine 84 minus 80, I get 4y. And now this has finally become real nice. I divide by 4, and my y-coordinate then is negative 6. So all the way back here, I get negative 6 for my y-coordinate. Now for the x-coordinate, well, if I really wanted to, I could take that negative 6 and plug it in here or here. But I'm going to go with let's go with one of these equations. You could, again, literally any of these equations you could plug that negative 6 into. It's just a matter of which one looks easiest to you. So what I'm going to do is I'm going to go with, I'm just going to go with this one. So I've got this equation, I've got 18, really running out of room now. 18 plus 10, but instead of y, I'm substituting negative 6 equals negative 7x. When I multiply again, 18 minus 60 equals negative 7x. I subtract these, I get negative 42 equals negative 7x. I divide by negative 7, and finally my value for the x-coordinate is positive 6. So my solution to number 16 is 6 and negative 6.